After discussing the endothermic and exothermic reactions, I want us today to talk about heat changes in physical processes. Let us start our discussion today by looking at latent heat. There are substances that can exist in three states of matter. That is, when the substance is undergoing some variation in temperature. For example, water can exist in a solid state, that is in the form of ice, or in a liquid state. It can also change to gaseous state, that is the vapor or steam. Now, when ice is subjected to heat, it changes to water, and what happens first? The temperature rises as the molecule absorb the heat energy. The heat energy absorbed is then converted to kinetic energy, as in the heat energy that is absorbed increases the kinetic energy. And due to this fact, the molecules, that is the particles, will begin to vibrate more vigorously, meaning there will be more collisions between the particles as a result of the increased kinetic energy. And as this continues, the molecule vibrate until the forces of attraction between the particles are overcome. During this time, the temperature remains constant as the ice melts into liquid state. So, just like we discussed in Form 1 chemistry, is that when you heat, the first thing is absorption of heat energy. And that heat energy absorbed is what increases the kinetic energy. And the increase in kinetic energy result into more vibration. It causes collation. And when the temperature now becomes constant, the collation continue until the force of attraction is broken. And that is enabling the ice to change into a liquid. The amount of heat energy required to convert a given amount of solid substance to a liquid at its melting point is what we call latent heat of fusion. Now, latent heat of fusion is the amount of heat energy required to convert a given amount of solid substance to a liquid at its melting point. That is what we call latent heat of fusion. While latent heat is simply the amount of heat energy required to change the state of a substance. At constant temperature. Now, when 1 mole of a solid substance is now converted into a liquid substance at its melting point, then the amount of heat required to do that is called molar latent heat of fusion. That is when we have 1 mole of a solid substance. When liquid water, we have seen there is formation of liquid. Now when this liquid water is further heated, the molecules absorb heat energy, which is then converted. This heat energy absorbed increases the kinetic energy, and in turn, the molecules vibrate more vigorously. And this will occur until the molecule have gained enough kinetic energy that will enable the force of attraction holding the molecules together to be broken. At this point, the liquid water boils without any further change in temperature as it changes to steam. the heat required for this now is what we call a latent heat of vaporization. Now, latent heat of vaporization is the amount of heat energy required to convert a given amount of liquid into gas or vapor. So, when the liquid water is now heated to change into gas, that is steam, then we call that amount of heat a latent heat of vaporization. So we've seen that the ice has changed to water, then on further heating the water, the molecules gain heat energy that will increase the kinetic energy, and the increase in kinetic energy will bring collision between the particles. And as the particles, or rather the molecules in water, continue to vibrate, they collide until the force of attraction holding them together get broken, and then that enables the liquid water to change to steam, and that is in gaseous state. When 1 mole of a substance of a liquid substance is converted to gaseous state, then we call it a molar heat, or simply molar latent heat of vaporization is converted to gaseous state. For example, converted to steam, then this is called molar latent heat of vaporization, or simply a molar heat of vaporization. Well, we have said that there are some substances that can exist in a solid state, a liquid state, and gaseous state, and we've seen that through looking at latent heat of fusion and latent heat of vaporization, whereby the latent heat of fusion involves breaking down the solid substance to change to liquid. Then latent heat of vaporization now involves the change of that the formed liquid substance to vapor as shown in the figure that you have below. So this is now heated. There is heating taking place, and then it happens so that once the force of attraction holding the liquid molecules together, or simply the water molecules, has been broken, then the liquid changes to vapor. As you can see, there is an increase in kinetic energy as a result of the increase in temperature, and that brings a latent heat of vaporization. Now, in the change of state, for example, solid to liquid, heat is absorbed. And as we said earlier, when heat is absorbed, then that is endothermic. And if the very amount of substance is cooled, now liquid cooled, heat is released. Meaning we have endothermic and exothermic taking place. Endothermic when you are heating, that is absorption of heat, and exothermic when cooling takes place. For example, when 1 mole of solid ethanol is heated, or simply converted to liquid ethanol, which is through heating, there is heat that is absorbed. So we have the endothermic reaction as follows: CH3, CH2OH for ethanol, that is solid ethanol, then is heated, it gives liquid ethanol. And the delta H is positive 2.39 kilojoule per mole, because we are using 1 mole. There is a molar latent heat of fusion, the breaking down. So this is endothermic reaction. Again, if the same amount of liquid ethanol is cooled, that is, if 1 mole of liquid ethanol is cooled, it forms back solid ethanol, and now heat is released. As the bond forms back, now we have a release of heat, and therefore the reaction is called exothermic reaction. Let us have that in equation. That will be CH3 CH2OH for ethanol, now in liquid state, then cooling, to form solid ethanol. Same amount, but now solid ethanol, delta H is equals to negative 2.39 kilojoule per mole. So that confirms that we require same amount. If the change of state is heating, cooling, solid, liquid, liquid back to solid, then we require same amount of heat. That is, amount of heat that was absorbed during the heating process is the same amount of heat that is going to be released during the cooling process. As you can see, the heating one has a positive value, then the cooling has a negative value, implying the process is endothermic and exothermic respectively. That is all about heat changes in physical processes.